All right, today we're going to cover our first GUI. And I think this will be really good because this will help you see how two applications work together, the different classes work together, and maybe give you a notion about like unit testing versus system testing and all those good things. So I don't know how much we'll get into today. There's several examples posted. We'll get through as many as we can today. And the ones I don't go over, please review them between now and next week, because next week we're also on this topic and we will also be covering those. So I have a very simple GUI. Just to start, right? You got to walk before you can run. That only has one class in it. First GUI class. And we're going to see how it runs first, and then we will look at how it works. Well, let's compile it. One folder down. All right, compile it. There's no errors. There is the class, so I'm going to execute it. And really simple GUI. We have enter the temperature in centigrade or Celsius. When I type it in, I will get the convert it to Fahrenheit. So if I hear that it is 13 degrees centigrade somewhere, it is 55 degrees Fahrenheit. Is that enough to test it? Of course not. I'm going to test some points that I definitely know. 0 degrees centigrade should be 32 degrees Fahrenheit, which it is. 100 degrees centigrade should be 212 degrees Fahrenheit, which it is. Finally, -40 is -40. That's the one number where Fahrenheit and centigrade is the same thing. So, okay, yippee, it seems to work. So let's look at the code. Now, in this case, again, I put the calculation right in the GUI. That is only for example purposes on this first example, all right? Typically, any of the work other than the GUI work is going to be handled in classes. And we'll see an example of that again, either today or next week. So let's open this guy up. And we'll look at it. And notice, first of all, we have some import statements right off the bat. Swing is one way of doing a GUI in Java. It's an older method, and if you were doing some Java programming, you very well might see some swing applications. There's another way, Java FX, but I think that's a little harder than swing. So we're going to use our first example called using in swing. Action listener and action event are two classes that relate to what happens when the user does something, namely what happens when the user clicks the button. Because they can enter a number in here, nothing happens until they click the button. So you need an object that is going to play the role of the listener. The listener waits for something to happen, and the thing that happens is an action event. And that action event, in our case, is going to be the click of the button. So my public class first GUI extends JFrame. JFrame is a holder and swing that can hold different panels. It implements Action Listener. What does that imply that Action Listener is? It implies that Action Listener is an interface. All right. So there better be code in this file that implements the methods that are described in Action Listener. Let's see what those methods are. We're going to pull up the official Java doc. You know, it's one thing to look at like someone's page that describes how to do it. To get the real lowdown about what is happening, go to Java docs on the Oracle site. And it inherits a bunch of stuff, or it inherits, maybe it doesn't inherit anything. Here's a list of classes that implement this. There is only one method that you need to implement in order to implement this interface, and that is action performed. Action performed, the return value is void, so there is no return value. And it accepts an argument of action event. Well, that action event is what occurred. All right. So look at our code. We have our action performed method described here. Therefore, I can implement Action Listener. If I remove this function, guess what? I remove that function. Guess what? I get an error. I get an error because the error pretty much lays out exactly what's wrong. First GUI is not abstract, and it doesn't override the abstract method action performed. So therefore, I can't say that this class implements the Action Listener interface. Another way of saying that it implements the Action Listener interface is to say it can serve in the role of an Action Listener. So our Action Listener is what puts interactivity into this window so that the user clicks it, something happens. So let's look at our statements. We declare 4 attributes of our window, our frame. A label that's going to contain the message in enter temperature in centigrade. Text field that allows us to enter the value of the text. A button with the title convert on it. And then a label for our results. Those are, if we run this, those are the 4 things on the screen. A label, text box, a button, and another label. Label text field, button, and another label. So the GUI is going to be the boss program. So it's going to be what we call when we want to start this application. Therefore, it needs a main method. And what does the main method do? The main method creates an instance of the first GUI class. Remember, static methods, I don't know if we went over static methods before. We think we just briefly mentioned them. You don't need an instance of the object to call a static method. So I can just call main from the command line by running this code. What this is doing is this is actually creating an instance of first GUI. So it's an object and its type is first GUI. That object has these attributes and this method. All right, let's see what the constructor of first GUI does. So the constructor is going to put everything in place so that we can display our window. First of all, we make the frame visible. We exit when we close. We exit the program when we close out of here. We then create a panel. Remember, this is a frame object. What do you do if you have a frame on the wall? You probably have a picture inside of it. You have or maybe you have a diploma or a letter that's important or something like that. And you could replace it, right? You could put a different panel in it. You could put a different picture in it, or you could put a picture on top of that picture or whatever, or have two pictures maybe in it. The panel is like the picture that we're going to put inside the frame. All right. So we create the panel. We're going to put stuff in the panel, and then we're going to put the panel in the frame. Now, this is a key statement. For button convert, which is this button that we declare here, we're adding an action listener. If we don't do that, guess what happens? Try to think to yourself what you think that will happen. You can enter data all day and click that button. Nothing happens. Why? Because no one, and I talk about this as if it's people, but no object is listening for that button, is waiting for that button to be clicked on. Therefore, nothing handles that code. So what button convert says is we're going to make the code that contains the action listener for that button. So the code that does what we want to do when the user clicks that button is in this object. And this object can be put in that role because it implements an action listener. And therefore, it's going to have this action perform method. And therefore, this is going to get called when this is executed, or when that button is clicked on. So this creates the association between this block of code and the button. What would happen if we didn't implement action listener? Yeah, we're going to get an error. We're going to get an error because you can only make something an action listener for a button or for any other control if it is an action listener. So it has to implement action listener for us to be able to assign it to a button or to some other field. So here we assign to that button this object for its action listener, which means that this object contains the code that happens when you click on it, and that is in the action performed event. All right, so at this point we have associated that button with this listener. Now, we're going to add all these controls to our panel. And we add them in order, the order that we want them. By default, it's going to orient the controls that we want horizontally. So the first thing I put on the page is going to be on the far left. The next thing is going to be next to that, to the right of that, to the right of that, to the right of it. So label temp, which says enter temperature in centigrade, is going to be all the way to the left on our panel. Then the text field for the temperature, then the button, and then the results label. If we don't do this, then we have a button object, we have a label object, we have a text box object. But guess what? They are floating in space somewhere because we have not added them to the panel. So we have to add them to the panel if we want them to be part of our GUI. And that's what this says. What these instructions do. Adds those controls. And by default, it will add them horizontally. We then get this frame's content pane, which is like the main picture in that frame, and we're adding that panel. If we didn't do this, we're not going to see anything, and I won't go through demonstrating it, just believe me. Why won't we see anything? Because we haven't added that panel to our frame. We haven't put that picture in the frame. And then finally, this set size is going to set the dimensions of it. And so when we start this up, we're calling a constructor, is going to do these things. It's going to make it visible. It's going to say to exit the app when we close the window. We're creating a panel to put all our things on. We're telling it that when you click on the button, call the action performed event in this class, and then add all these things to the panel, add the panel to the pane, set the size, and therefore, when we run this, we have our GUI. Now that's going to sit there until we close it or enter some data and put some value in. At that point, it is going to do, I click the button, it's going to perform this action perform event. And I'm going to pass it some information about exactly what happened. That's not really necessary in this case because the only actions we're performing is clicking on that button. That's the only thing we're interested in. So I don't have to pull any values from that event object. So what am I doing? I'm creating a variable for centigrade. I'm putting a variable for Fahrenheit. I have these wrapped in a try-catch. I grab the value from the text box, text field, and I try to convert it into a double. So a text field contains any text that you want to. So I could run this and I could put just letters in there. Well, we have to try to convert that to double before we can do math on it. So that's what this statement does. It says take the value of that text field and, if possible, convert it to a double. Well, guess what? If we entered in something non-numeric, that's going to throw an exception. All right. What do we do then? We'll hit this catch instruction that is going to go and set the label results to tell us that we've had invalid input. Otherwise, we do this calculation and we set the results field to be our answer. Compile it, run it. I put garbage in here, tells me invalid input. Why? Because when the button was pressed, we do this method. We try to convert the garbage that I typed in that text field to a number. It threw an exception, therefore we catch that exception. Now, how do I know that that's invalid input? How do I know that that's the problem? Really, nothing else could go wrong in this. You know, this is straightforward enough, right? This is just math. Java's not going to be able to do this equation. The only thing that can go wrong is that when we try to parse that double, right? A general rule, you put a try-catch in where things are sort of out of your control. So we can't control what the user types in. So we better wrap the instructions that pulls the data from that text box in a try-catch, especially if we're going to convert it to numeric. So, okay. Put in the value, convert, and it does the calculation. Any questions about this? That's the basics of a GUI. We'll see this over and over again. It's going to have attributes of the things that are going to be on the form. Constructor is going to do some of these things. It's going to create at least one panel. And it's going to assign an action listener to any buttons that we have. It's going to add the things to the panel. It's going to add that content pane. And then we'll have our action performed to do the stuff that we want to do. That's sort of the recipe for this. All right. Now, there's a couple different ways that you can assign an action listener. This is one way. This is method one. I closed it. This is method one. We implement, our frame implements the action listener interface, and we have set action performed in it, and therefore the code that processes that form, I keep using the word form, I probably will, Java frame, all right? The code that processes it is included in the frame itself because I've implemented action listener. There's a couple of other ways to do this too that you might do. And actually I did this. I think I have two buttons on this example, and I did it each of the two other ways that you can do it. So I've added a second button. One button converts centigrade to Fahrenheit, one converts Fahrenheit to centigrade. So let's watch how this runs. It's pretty much like it did before, except a couple things. First of all, it's laid out different. I will say this now. We're not going to focus on making sure our layouts look pretty as long as they're functional. Okay, so don't worry about this too much. Obviously, it needs to be legible and readable, and you need to be able to understand it. But I wouldn't spend too much time worrying about this. So that's the one thing that's different from this example than the previous one. The other difference is that we can calculate centigrade to Fahrenheit, or we can calculate Fahrenheit to centigrade. In either case, if we touch that, we get invalid input. So let's look at the code and see what enhancements we have in this case. First of all, you will notice that I imported something called border layout. Border layout is one way of implementing the layout on a page. As it turns out, I don't even use that in this example. I use the box layout. I have the code for border layout commented out, and we'll look at that after we're done. All right, two ways that we do it. First of all, you notice that this doesn't implement that interface anymore. So this can't be the object that takes care of the clicking. What object is taking care of the clicking? In this case, it is the new C2F object. And if we scroll down here, we see inside of this class, we see another class defined. Notice that, again, this class exists entirely within the code for this class. This is what's called an inner class. Which makes sense, right? It's inside the other class. The action listener is probably going to only work with this one window anyhow, so it doesn't matter that we're not getting reusability out of it. So we create this class. This class implements action listener. Therefore, this class has to have the action performed, and we go and we do its thing, and we do the conversion, and this essentially was the code that was in the other example. I just moved it here. Now it's able to pull this value from the main class because it's an inner class. It's inside of it. It can access the attributes of the outer class. There's another way, though, that can be a little confusing to read. I can actually create a new class right here, and it's a class that doesn't have a name. It's called an anonymous class. So normally, I would have the class here. But instead of actually having a different class, I have the definition of a class, a new action listener. And if I make a new action listener anonymous class, I still have to follow the interface and have the action performed. Now, it doesn't matter to me which of the three methods you use. You can either make the frame the action listener. You could create an inner class to do it, or you can create an anonymous class. I would like you to understand all three of these methods. This is the code then that gets called when I say convert Fahrenheit to centigrade. It grabs a value from the text and does another calculation to get the results in centigrade. So do go over this example and make sure you understand the different ways that we can create action listeners. All right. So much for this example. Let's go up and look at our next forms example. This plays a game that if you're in my other class, My 243 class, you've seen this game already. This is called the high-low game. In the high-low game, you roll 2 dice. All right? And you guess whether the dice are going to be high, low, or 7. Low is defined as the total of the dice being 2 through 6. High is defined as the total of the dice being 8 through 12. 7 is the value of the dice is going to be 7. Now, the odds are against you in this because it only pays out 4 to 1, even though your chances are 6 to 1 against rolling a 7. And your odds of rolling, it pays out 1 to 1, and your odds of rolling a low or a high are actually a little less than 50-50. So like all gambling games, it's rigged in favor of the house. Let's see how this behaves. And let's see what classes we have out there. So this is the ultimate that we have here. We have the high-low GUI, which is our boss program. This is taking the place of our test class. Where it pops up and we start out with 100 points, we guess. Do we think it's going to be low, 7, or high? I'm going to say it's going to be 7. It's low. We lost. I'm going to guess high. It's low. We lost. I'm going to guess 7. It is 7, so I won. Right? Yay. So this is our end goal, right? This is our final product for this application. Notice, though, the classes I have here. I have a dice class. I have a high-low game class. And I have a dice test, a high-low game test, and then the GUI. So here's how this could work. Let's say we were developing this. And it might be that it's my responsibility to develop the dice class, right? That's my job, to create the dice class. Someone gives me the specifications, what functions it should contain, and so on. I create the dice class. It might be someone else to create the high-low game itself. The logic of taking the guess from the user or taking the value of the guest and rolling the 2 dice and seeing what the total of the dice are and so on. And then there might be a third person that brings those together into the GUI. Now, before I turn my before I turn my dice class over, I want to make sure it works. I'm not just going to take my first stab at writing a dice class and be done with it. So I have a dice and a dice test class. Let's look to see what they do. Here's the dice test class. And here is the dice class. Okay. The dice. Pretty simple class, right? Dice has one attribute, the value of its face. When I create the dice, I also roll the dice. What does rolling the dice do? It sets that face value to be a random number. I hope between 1 and 6. All right. I think that is the code to write to generate a random number between 1 and 6. Right? But I've been wrong before. All right. And so rolling randomly sets the face value and returns the results. Get simply returns the value that's showing on top. Right, that makes sense. This is a model in software of a single die. Now, how do I know this works? Well, there's randomness here, right? I can't create a unit test class that rolls the dice and looks at the number and say, well, was it supposed to be a 2? I don't know. It's random. Well, what I can do for the dice test class is do this. I can run the roll of the dice 10,000 times. All right? So I create my dice object. I have 6 counters to count how many times each of these numbers were rolled. I have a value and I have my dice object. I loop through this 10,000 times, roll the dice, and then I have a switch statement, which is like a series of if statements. Now, according to this code, if I didn't roll a number from 1 to 6, then the sum of my 10,000 wouldn't be 10,000. The sum of my 10,000 rolls wouldn't be 10,000, right? If it only generates 1 through 6, then I should be able to add up how many 1s there were, how many 2s there were, how many 3s there were, and it should add up to 10,000. So if my code was wrong to generate a value from 1 to 6, I'm not going to get a total of 10,000 rolls because it's going to not count some of the rolls. Another thing about those, with 10,000 rolls, they should be close to 1/6 apiece. It's not going to be exact, all right? But if, for example, I rolled out of 10,000 rolls, I had 5,000 of them that were 1s, there's something wrong with my dice, okay? Because I should only have, let's make this, let's go up to 12,000. Easier to do the math on. I should have 2,000 a piece for each numbers, right? If I roll it, if it was perfectly 1 out of 6, they would be 2,000. Now, nothing is perfect like that. If you roll a dice 10,000 times, if you roll a physical dice, you're not going to exactly get 1 out of 6. It's going to be a little off, but it shouldn't be way off. So that's how I'm going to test my dice object. So I save this. I compile it. Again, I'm the guy that wrote the dice class, so I'm going to test it before I turn it in for the next person to do their work. And I look, well, they're all in the 2,000 ballpark. And if I added them up, okay, that's 5, 10, 30, so 3, 4, 5, 6, 7, shoot, 5, 5, 8, 16, 20, so 2, 5, 6, 7, 0, carry the 1, 9 and 1 is 10, so carry the 1, add these up, it'll be 12,000. So there's exactly 12,000 rolls accounted for. So I'd never generated in 12,000 rolls a value that was not 1 through 6. And it's approximately an even split between them. I could run it again and get different results. Some that have a little more, some that have a little less. but they're all in the ballpark. All right, so I can say, I think my dice test is correct. Because if my dice was wrong, then the person that is creating the test for the games or creating the game class and the test for it, they're liable to get screwy results, right? So let's look at that class. I'm going to close this because I know I don't need this guy anymore. I think it works. Not a guarantee, but it sure seems like it works. So I'm going to look at my game class. It has 2 dice. When I call the play, I throw an exception. This argument of choice, what I've done is I've made it so that your choices are 0, 1, and 2. So if this class gets a value that's not 0, 1, or 2, it's going to throw an exception. 0 means low, 1 means 7, 2 means higher than 7. So I roll my 2 dice. I add up the total of them, set my payoff to 0. If I chose low, put comments in to explain what's going on here, and it's less than 7, then I win. Otherwise, I lose. If I picked 1, that means the player chose 7. If the sum is 7, then I win 4 times my bet. Otherwise, I lose my bet. And finally, I do the same thing for greater than 7. I have a couple other methods to get the values of the dice. How do I know that this works? Well, I have a test class just for this. Now, again, how am I going to do this? I could randomly play it, and hard code certain values and tests and all that, but even that wouldn't produce good results. So I'm going to automate the testing. And I have this go through 100 times. I could make it more. I could do it 1,000 times. Let's just keep it at 100. And I could look at these. It'll take you a minute to look through 100 of them, but hey, if you want to be sure that your code works, you got to take those steps. We're going to look at this. First one, I rolled a 7, or I rolled an 8, and I picked 1 and bet 1, therefore I lost, right? Because 1 means I picked 7, and these add up to 8. Here, I rolled a 7, and I picked 2, so I lost again. Here, I picked 9, and I picked 7 again, so I lose. Here, I rolled 7, and I picked 7. And I win. I was being a little suspicious here because I was choosing a lot of 1s. Did I code it to do that? No, I haven't randomly picking it. It's just a coincidence where it's picking. That might be well, you could look and see how many times it picked 1, 2, and 3. The bottom line is I can examine these. And is it processing the code? Is it processing the game correctly? Then when it works, we're ready to put everything together and system test it along with the GUI. So let's look at the GUI. All right, I've imported all these things because I have other stuff in here that we need. Because we're going to pull the image of the dice. I'm going to give you the 50-cent tour of this program, and we'll pick up the rest of it. You know, look at it between now and next Monday, and we'll pick up here going in more detail for this. I have all the things that are going to be on my page. Points. Make a choice. A list of my options. I have a combo box, which is like a drop down that's going to contain these options. I have a button that says play. I have some labels. And then I have an instance of my high-low game class. All right. Because again, the high-low game class is what does the work, does the calculations. The GUI should rarely, only in the case like I showed you before for demonstration, the GUI is not going to do any of the work. I did it in the centigrade calculation because I just wanted to demonstrate GUIs. But the GUI is going to be separate from the functionality. That's an important concept. We separate things all the time in programming. In web development, we separate the HTML from the CSS. In other programming, we separate database operations from the way the page looks and the code. Here we're separating the logic, the business logic or problem domain logic from the GUI. On main, I create an instance. I do all the things that I do. I create an action listener. Add all my things to the panel. When the action's performed, what do? I get the value of the option from the option list. In other words, did they pick 0, 1, or 2? I assume my bet is 1 because I don't have a text box for 1. I then call play method in my game class. I don't need to worry about the dice object. The game class takes care of all that. The game class takes care of the rules of the game. All I have to do is wire those two things together, wire the GUI with the game class. And then if the payoff is less than 0, I know I lost. If the payout is greater than 0, I won. And then I do some stuff, including finding the images, and output that. We'll go over this in more detail next Monday. So if you do go over this, take some time to go over this and get a head start on that. Take a look also at the other examples I have in the week 11 module. All right, that's all I have for today. We will see you in lab or next week. Take care.